Welcome to Science Access. In today's class, I'll be talking about atom, atomic structure, and molecule. If you know you are new to this channel, please kindly press the subscribe button and put on the notification so that you get notified whenever I post a new video. What is an atom? An atom is the smallest particle of a chemical element or of an element that can actually exist and take part in a chemical reaction. Know that the smallest bit of anything is regarded as the atom of that particular thing. So a basic unit of the element is actually what we regard as what? The atom. Now, let's talk about atomic structure. You remember I made mention of elements. We actually have about 118 elements in the periodic table. And we'll be describing how you can actually give a little bit basic structure of an atom. Atom generally is comprised of the nucleus and the shell. So let's use oxygen as an element to explain atom. Now, oxygen has an atomic number of 8 and a mass. So let me draw the atom of oxygen. Remember I made mention of the fact that atom is comprised of two things. Number one, the nucleus. Now, these are the electron shell. These are the electron shell. All right? Now, note, inside the nucleus, you are seeing the positive sign here. You're seeing the positive sign inside. Now, I'm using the positive sign to represent the proton. Proton is positively charged and is found inside the nucleus. Now, you can see the circle or the zero sign inside. I'm using the zero sign to represent neutron. Neutron is neutral. It is not positively charged and is not negatively charged. It is neutral. So I'm using the zero sign to represent neutron. In oxygen atom, atomic number is 8. The reason that the atomic number is 8 because there are actually 8 protons in the nucleus. Now let's count the number of protons in the nucleus. You have 1, 2, 3, 4, 5, 6, 7, 8. Because oxygen atom actually have 8 number of protons, oxygen has an atomic number of 8. Now let me give you something. You realize that the periodic table is arranged. Now the way they are actually arranged according to their atomic number. So the first element there has an atomic number of 1. Second has an atomic number of 2. Now if you look at the periodic table, you realize that if you count, you have, this is hydrogen, this is helium. Now I will have to actually put the diagram of periodic table on the board so that, and I will use arrow to count 1, 2, 3, 4, 5, 6, 7, 8. Now you realize that oxygen is actually occupying 8th position in the periodic table. The reason is that it has a proton, has 8 protons in this nucleus. Now, apart from the proton, you are seeing another cycle there. This means what? The neutron. It has also 8 neutrons in this nucleus. So mass number is the number of proton plus the number of neutron. So if we are to calculate the mass number of oxygen in this place, it's now 8 plus what? 8. In this case, it is 16. So oxygen has an atomic number of 8 and a mass number of what? 16. This is the simple concept regarding the atomic structure. Now let's talk about something else. We have mentioned the proton. We have mentioned what? The neutron. Remember, inside the nucleus, we have the proton plus neutron. All right? Now, in the shell, we have another subatomic particle regarded as the electron. Note, we have 3 subatomic particles. Number 1, proton, positive side. Number 2, neutron. And number 3 is what? The electron. I'm representing the electron with this star symbol. Now, note that electron is negatively charged. That's the reason why you see sometimes some textbooks, they put a circle with a negative charge inside representing the electron. One fact that you must note, in a naturally occurring element that is not reacting, the number of protons must be equal to the number of electrons. Note that the number of protons must be equal to the number of electrons. So since we have 8 here, we're also going to have 8 electrons. But the first shell actually takes only 2 electrons. So that's the reason why I drew the first shell. I put 2 electrons there. And the second shell takes maximum of 8 electrons. So, but how many do we have? We only have 8. So I put 2 in the first shell. The remaining 6, I put it in the second shell. But the second shell can actually take more than 6 electrons. So this is the atomic structure of oxygen. Now, I would like you to try the atomic, I would like you to go with me while I draw another atomic structure of calcium, which has atomic number of 20 and a mass number of 40. Let's take a look at the atomic structure of calcium. Now, calcium is represented calcium, Ca. All right, this is a symbol for calcium. I'll make a separate video for the 20 elements. All right, when we are talking about the periodic table. Okay, so calcium has atomic number of 20. Is number 20 in the periodic table. All right, so if you count the number of proton inside, it is 20. Sometimes we could just use P equals to 20, meaning we have 20 proton in the nucleus, and N equals to 20, meaning we have 20 neutron. Now, atomic number is now 20, and mass number is this plus this, which is 40. Proton plus neutron. Now, the electron. Note that this first shell is called the K shell, and the K actually accepts 2. You can see the 2. Remember, when I was drawing the atomic structure of oxygen, I made sure the number of proton must be equal to the number in their natural state. So it means that we'll have 20 electrons, just the way we have 20 proton. Now note, because we have 20 plus and 20 minus, the atom is neutral in its natural state because the plus will cancel out the minus, or the positive will cancel out the negative charges. So it's actually neutral. Okay, so the first shell we collect 2 K shell. The second shell is the L, third is the M, and fourth is what? The N. Now, this will take 8. This will take 2. The second will take 8. The third will take 8. Now, 2 plus 8 is 10. Plus 8 again is 18. So the total that this one is covering is actually 18. All right. Now, but this third shell is actually carrying 8. While the last shell will just have 2 electrons. So we put the last 2 electrons. Remember, the first 8, second will take 8, third 8, and the fourth 18 is already covered, so we have only 2 left. The 2 last one will now be in the N electron. So this is a simple structure of the atomic structure of calcium as an element. Let's quickly talk about the molecule. Now let's talk about molecule. We can have a molecule of an element, and we can also have a molecule of a compound. Now let's talk about the molecule of an element. You realize that the molecule of an element is actually formed when 2 or more atoms of that particular element come together. So that is how it is formed. And why do they actually come together? Now let me tell you this. This is just a secret. As humans, we can get hungry and we want to be fed. So they are the same thing is applicable to atoms. Atoms have a structure that is stable. If they are in an unstable state, they want to achieve that stability. Now, let me explain this using the structure on the board. Now, remember, I mentioned the fact that the first shell, K, has maximum of 2 electrons. The second shell has maximum of what? 8. Now, for example, this is oxygen atom. It has 6 in its second shell. It has this innate desire to have a complete structure, which is having 8 in this atomic shell. So I will now tell him that this second shell is hungry, this atom is hungry, and wants to attain a state whereby this second electron has a maximum of 8 electrons. Once he attains that, it is now stable. So that is actually the drive for chemical reaction in chemistry, to attain stability. All right, so let's take a look at this. Now, this atom is present in an unstable state. It has 6 electrons in its atomic shell. This is an atom. Now, there's another atom present in an unstable state having 6 electrons in its atomic shell. These two can decide to come together and share the electron, then form a stable state. How do they do that? Now, let's take a look at this. Remember, This is present in an unstable state, and this is present in an unstable state. Now, take a look at this. This is having 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Both of them now come together. Now, this contributes, this first one contributes, this first contributes 2, and this contributes 2. Now, this is having, let's differentiate the atom of this from that of this. This is having 1, 2, 3, 4, 5, 6. Now, why this is having 1, 2, 3, 4, 5, 6? This is contributing 2, and this is contributing 2. So they have contributed 2. So this last atomos share of this, let's now count the number of electrons in this atomos share. We now have 1, 2, 3, 4, 5, 6, 7, 8. So this share is now having 8 in this atomos share. It is now stable. Now let's count the number of electrons in this second atom. 1, 2, 3, 4, 5, 6, 7, 8. So this is the reason why you see oxygen in nature existing as O2. They come together, they share electron, which is a covalent bonding, and they now form a molecule. So these two atoms coming together, remember, this is a separate atom, this is a separate atom. They now share electron to form what? A molecule. They've joined chemically to form what? A molecule. Let's take a look at a molecule of a compound. When I'm explaining chemical bonding, electrovalent and covalent bonding, I will explain this in details, but let's just take a molecule of a compound. Now, let's take a look at a molecule of a compound. Let's use a common compound that we know, the table salt, sodium chloride. All right, this is the common salt that we know. So this is the structure of sodium. Now, if you take a look at your periodic table, you realize that sodium is present at the 11th, is the number 11 atom. 11th atom. All right. I want to take a look at periodic table. You realize that it's actually present in the period 3 and group 1. But I will explain that when I'm talking about the periodic table. All right. So in this case, sodium, remember, is 11. So we have proton as 11. In this case, this is mass number. A neutron is actually 12. So proton 11, neutron 12. So the atomic number in this case is 11. Atomic number is 11, and mass number is actually 23. Remember, mass number is actually the number of proton plus the number of neutrons. So I will now put the proton is present in the nucleus and neutron is present in the nucleus. Now let's put the shell. Remember, our first shell will take 2, which is the K shell. Our second shell will take 8. So this is 2 plus 8, that is 10. So we now have 1 electron left. The electron is present in the atomos shell. We'll put it there. Now, for chlorine, is actually number 17th atom, and the number of proton is 17. All right, while the number of neutron is 18. Remember, chlorine, there is a case we regard as isotopy. So, but I'll describe that where this number, in some elements, this number is different. We'll talk about that in another separate video. All right. Now, take a look at this. Since the number of proton is equal to the number of electrons, that means the number of electrons in this case is actually 17. So we now have to put the 17 in the shell. The first shell will take 2, which is the K shell. The second shell will take 8. Third shell will take another 8. So 2 plus 8 is 10, plus 8 is 18. So this is actually wrong. All right, so let's quickly correct it. We have so this is okay now. All right, and this is okay. So we have 17 electrons. So this third shell is carrying 7. Remember, electron is 17. First shell takes 2. Second shell 8. 2 plus 8 is 10. Then the third shell is just remaining 7. So the third shell will take the 7. How many electrons does this need to complete the 8? Just 1. How many electrons does this need to complete 8? 7. So this group, they cannot share electron. They cannot. It's easier for this one to just give out this last one. This one will give out this last one. And this one will now have just 2 shell having a stable state, while this one will now have 3 shell having a stable state. So this one will move from here to this place. So this one will now have an extra electron. Remember that proton is positive 17. Electron is positive, is negative 17. So it will cancel out. But if one extra minus or negative charge now move into this, this one will now have an extra minus sign. So this one will now have. While if minus leave this place, this one will now have an extra plus sign. So this one is now positive. So this one is losing. Remember, we have proton, 11 proton, which is 11 plus, then an 11 minus, plus an 11 minus. So if one minus leaves this place, which one electron leaves this place to this place, we will now have 10 electron. It has ionized. We now have 10 electrons. So here is now 10 electrons. So here will now be left 10. We cancel out 10 minus. We will now have 1 extra plus. So here will now be positively charged. Now, if this extra negative charge have moved to this one, the electron that moved to this place to complete this shell, here we now have 1 extra electron. So these 2 elements, Na plus Cl, they combine to form NaCl. Now the Na is positive, while the Ca is negative. This attraction between this positive and this negative charge is what actually keep this molecule or this compound together. So we now have NaCl plus. This kind of bond is actually called ionic bonding or electrovalent bond. So this is how a molecule of example of how a molecule of a compound is actually formed. Note that a molecule is formed by a combination of 2 or more atoms. All right. So I have explained how a molecule of an element is formed and how a molecule of a compound is actually formed. When I'm talking about chemical bonding, I will explain in details all the various types of bond that can occur in both elements, molecules, and as well as a compound. Thank you.